Quick example on implicit differentiation. So we have the tan inverse of x over y equal to e to the x plus y multiplied by sine 4x. So there's lots of things happening in this function. And we're going to try to differentiate both the sides separately to begin with. So for the left side, tan inverse of x over y. Now we already know that the inverse of tan has a derivative of 1 over 1 plus whatever is inside this bracket squared. So we have 1 plus x over y in this case, whole squared. But of course we know the chain rule is being applied here since the brackets are holding a function within themselves. So we need to now find the derivative of whatever's inside this bracket. So this will be multiplied by the derivative of the inside, which is a quotient rule. So we have the derivative of x, which is 1, multiplied by y, minus the numerator as it is, multiplied by the derivative of the denominator, which would be x times y prime. On the denominator goes the denominator squared. Of course, these are formulas you need to memorize. On to the right side now. So e to the x plus y. We know the derivative of e to the power of anything is e to the power of itself. So this would be e to the x plus y multiplied by the derivative of the power itself, which in this case again is a function, and the chain rule must be applied. So we have the derivative of the power, which is 1 plus y prime, multiplied by the next part, which is sine 4x. Of course, we are applying the product rule here. We have two different functions being multiplied together. So we take the derivative of the first and the second as it is, add it to the derivative of the second and the first as it is. So we're going to add this to the first function as it is, and the derivative of sine 4x. The derivative of sine is cos, so we have this multiplied by cos of 4x, and then cos 4x multiplied by the derivative of 4x, chain rule again, so we have that being multiplied by 4. Of course this looks like a mess right now, but really we're done with the differentiating bit. All we have left to do now is to make y prime the subject of the formula, and we'll have our implicit differentiation done. So, starting off from the left side and trying to simplifying this, all I can see really is we could try to write this as one fraction. So we multiply the numerator, we get just y minus xy prime, y minus xy prime multiplied by 1. And the denominator, if I'm trying to multiply, I would get y squared times 1 as y squared, plus x squared over y squared multiplied by y squared. The denominator cancels and I'm left with just x squared. Hope you follow. That would equal to the right side, which for now I'm going to write as is. I'm just going to rearrange so I could see things clearer. I have sine 4x multiplied by e to the x plus y, all of that being multiplied to 1 plus y prime, and that added to e to the x plus y, multiplied by cosine 4x, and of course I have a 4 which I'm going to stuff right in the beginning. On to the next line. This fraction right here, I don't think there's much I could do to it for now, but my right side is where I've really got strategies now. So I could expand this bracket and get the y prime, try to isolate it onto this side or even this side, and write the entire function in terms of it. So let's expand first. This would be sine 4x e to the x plus y times y prime added to sine 4x multiplied by e to the x plus y. So this bit is just that being multiplied by the 1, and then this first half is that function being multiplied to y prime, we're just expanding. Added to the next part, which I really don't see much I can do with, so I'll leave it as it is. Now, I can split this into two different fractions. One would include the y prime, and one would not. So I can take the part which doesn't on this side, and the y prime on that side. So I have y over y squared plus x squared, I'll show you exactly what I mean, minus xy prime over, oops, that's a prime, y squared plus x squared equal to the rest as it is for now. It's beautiful how we're nearing our final conclusion, step by step. That's all the math's about. E to the x plus y added to 4e to the x plus y multiplied by cosine of 4x. Now I have two terms in all my functions combined, which include the y prime. So I'm going to get them on one separate side, factor out the y prime, and make it the subject of our equation. So I'm going to get, by bringing this onto the left side, negative y primed sine 4x multiplied by e to the x plus y minus xy prime over y squared plus x squared equal to, we've taken this fraction to the other side so it becomes a negative, negative y over y squared plus x squared added to sine 4x multiplied by e to the x plus y added to 4e to the x plus y times cosine of 4x. Now onto the left side, I can take y prime common just as I planned. I have y primed and then sine 4x multiplied by e to the x plus y minus x over y squared plus x squared equal to the right side just as it is. Really running out of room here. Plus x squared, that's a negative, added to sine of 4x times e to the x plus y plus 4e to the x plus y multiplied by cosine of 4x. The last step, y prime is being multiplied here, so if I take this entire function to the right, it'll be divided, and I'm left with y prime is equal to the numerator, which would be the right side of our function, plus sine of 4x to the x plus y, that belongs to the e, added to 4e to the x plus y, multiplied by cosine of 4x, and our denominator would simply be this entire bit. Sine of 4x times e to the x plus y minus x over y squared plus x squared. That is our final differentiated form of tan inverse of x over y, blah blah blah. Thank you.